Welcome to production process unit 1 session 2 outcomes of the session. So we have already seen the SO1 industrial sand casting process. Under that explained 1.1 explain the procedure of sand casting process. This is what we have seen in the last video. So this video will see explain the types of pattern and pattern allowances, SO1.2. And recap, in the previous session we have seen foundry, classification of casting process, sand casting procedure, mold preparation tools and equipments. This session we will see pattern. Pattern is used to create the mold cavity, and pattern is the replica of casting to be made with certain modifications. The main modifications are the addition of pattern allowances and the provision of core prints. So pattern allowances we'll see later, and core print is the place that is used to hold the core inside the cavity. So to carry the core inside the cavity, core prints are to be provided along with the pattern. So therefore the pattern is slightly modified. For pattern size will be the casting size plus allowances. Pattern material. So pattern is normally made up of wood, and normally it is a teak wood, mahogany or white pine. If in the case of metal pattern, it is made of cast iron, brass, aluminum or white metal. Can also be made using plastics, plaster of Paris, wax, resin. Now for longer life, you can go for either a metal or a wood pattern. For complex, smaller quantity production, go for plastics, plaster of Paris, wax or resin. Types of patterns, and there are various types of pattern, and types are solid single piece pattern, split pattern, match plate pattern, cope and drag pattern, loose piece pattern, sweep pattern, skeleton pattern. And we'll see single piece pattern. For the entire pattern is made of a single piece. But this is a solid or single piece pattern. If this pattern is can be removed easily from the mold, then you can go for a single piece pattern. And split or two piece pattern. For if it is difficult to remove the pattern from the mold, you can go for two pieces, one for in the drag and another one in the cope box. And the match plate pattern, and if you have to match these two plates exactly aligning with each other, you go for a match plate. Therefore there are two halves with the plate. For these two plates can be joined together with double pins. So this is a match plate pattern for exact alignment of the two pieces. The next type is cope and drag pattern. So you can see here along with the pattern you have a riser pattern and the gating system. So this contains the entire gating system with the riser for along with the pattern. Next is the loose piece pattern, where you can see here the pattern has made up of more than two parts with loose pieces. These loose pieces are made because the pattern is difficult to remove from the cavity. Therefore, first pattern solid pattern will be removed first, then these loose pieces will be removed later. And sweep pattern. Here it's not a solid three-dimensional pattern. It's a two-dimensional pattern. So for the cavities produced by swooping this two-dimensional pattern about a vertical axis. So this is a sweep pattern. Then a skeleton pattern. So instead of making a complete solid pattern, a skeleton pattern will be made of bones. So that an internal cavity will be filled with sand. So this is a skeleton pattern. And then we'll see pattern allowances. So pattern is slightly made larger than the cast component because of these allowances. First allowance is shrinkage allowance, second is draft or taper allowance, third is distortion allowance, fourth finishing and machining allowance, fifth is shacking or wrapping allowance. So first we'll see shrinkage allowance. The metal shrinks on solidification and contracts further on cooling to room temperature. So normally all metals on cooling will shrink. Therefore, there are two types of shrinkages: liquid shrinkage and solid shrinkage. So during initial phase of solidification, the metal shrinks in the liquid stage itself, and that can be compensated by providing riser. For riser well supply material during initial liquid certification. But during solid certification, once it is certified, there is no, it has become solid. Therefore, there will be further shrinkage because of reduction in temperature, and this can be compensated by making the pattern slightly larger than the component, so that when the metal shrinks, it will occupy the required shape, and this is shrinkage allowance. Shrinkage allowance is specified by per meter over each linear dimension. For every meter length, this much amount of of allowance has to be provided on the pattern. And draft or taper allowance. So this is a provision on inclination of vertical surface of the pattern is called draft allowance. So it is provided for easy removal of a pattern from the mold. So you can see here there are two figures given. The first figure you can see where there is a pattern without draft. The second figure you can see pattern with draft. So for the first case, when you try to remove the pattern from the mold, there is a chance that the mold cavity is getting damaged. But in the case of a pattern with draft, if you provide a draft allowance, and it will be easier to remove the pattern from the mold. So for easy removal of mold, we have provided draft allowance, which is also called as taper allowance. You can see here vertical surface are given some taper so that it will be easier to remove the pattern. And you can see here draft allowance varies with complexity of the job. There is how complex the component is, and inner details of the pattern require higher draft than outer surfaces. Next allowance is distortion allowance, and it's not required for all castings. It is required mainly for U or V shaped castings, where you can see during certification the U or V shaped castings distort in different locations. Therefore, the distortion can be compensated by providing initial distortion in the pattern itself in a direction opposite to the direction of distortion in the casting. For distortion allowance has to be provided for U or V shaped castings. Next allowance, finishing or machining allowance. So after casting is certified, or some part of the casting requires machining, so that it can be attached to some other part. For wherever machining is required, extra material is required on the casting, and that's why the pattern is made slightly larger in those areas which require machining. And this amount of finishing allowance depends on the material of the casting, size of the casting, volume of production, method of molding. And shaking or wrapping allowance. So this allowance is provided to compensate for shaking. So when you try to remove a pattern from the mold, we insert a draw spike into the pattern and we slightly shake the pattern to remove the pattern easily. So during shaking, what happens is the cavity enlarges. Therefore, to compensate this, the pattern has to be made slightly smaller, so that when you shake, the cavity will be of required shape. Therefore, this allowance is a negative allowance. All other allowances are positive allowance. This shaking or wrapping allowance is a negative allowances. And that's all about the pattern. And so far, I have seen what is pattern and pattern material, pattern types, and pattern allowances. Thank you. We will see the remaining part of Unit 1 in the next videos.